every morning with drive. Been on the grind, know I had to survive. We had to win. Started from the dirt and the rubble. I had to be the needle that was popping your bubble.
Hello and welcome into the Rookie Prospect Profile Series, a Zilla Fantasy Elite production. Today we're going to be looking at running back Zach Charbonnet. Zach Charbonnet was drafted number 52 by the Seattle Seahawks, and they come into the league out of UCLA College after transferring from Michigan. Looking at some of their physical traits, we can see that Zach Charbonnet comes in with a height of 6 foot, 214 pounds, and a BMI of 29.0. They had a 40 time of 4.53 and a speed score of 101.6. Putting their physical traits along with some of their college numbers into the RStudio model, we get a prospect score of 15.678, which ranks 53rd overall out of the 310 running backs in the RStudio model's database. Shifting over to see who are the closest comparables to Zach Charbonnet's prospect score, we see that the next closest better than him are Carlos Hyde, J.K. Dobbins, Rachaad White, LaShawn McCoy, and Charles Sims. The next 5 closest below are Felix Jones, Keyshawn Vaughn, DeMarco Murray, Latavius Murray, and James Conner. So you can kind of see some pretty good outcomes in there. Carlos Hyde, J.K. Dobbins, LaShawn McCoy, really good. DeMarco Murray, Latavius Murray have been pretty solid. James Conner have been pretty solid. But then you got some busts in there too. Charles Sims never really did much. Felix Jones wasn't that great. Rachaad White, the jury's still out on him. But those are an idea of the next closest comparables in the RStudio model. Switching now to the machine learning model for Zach Charbonnet, we can see that Zach Charbonnet comes in with a mean of 13.51, a median of 13.48, a minimum prediction of 7.81, and a maximum prediction of 18.45. We can also see that their 10th percentile outcome is 10.96, their 25th percentile outcome at 11.96, their 75th percentile outcome at 15.04, and then their 90th percentile outcome is 15.92 with a mid-50 gap of 3.07. And the rankings for each of these can be found up, amongst the 36 players I modeled in the 2023 class can be seen here. Kind of getting into some of these numbers, the mean median range of about 13.5 there, just to give you an idea of what kind of players are, in that range in terms of their career best fantasy points per game in a PPR setting. We're kind of looking at actually the exact 13.51. That's actually Kenneth Walker's season from last year, his rookie year. It's just below Clyde Edwards-Helaire's, season when he was a rookie. We're looking at guys like Duke Johnson, Chris Ivory right in that 13.5 range, a little bit above Ronald Jones' best season, Ronnie Brown's best season. Jamal Williams at about 13.3. So that's kind of the range there, the median range, comparable to those particular players. And then kind of looking at their maximum prediction, that 18.45 there, that kind of, when we look at the 18.45 range, we're looking at guys, if you remember Noshan Moreno out of Pittsburgh, he had a really good season. That was 18.5. Peyton Hillis out of Cleveland in his big year, he had 18.43. Leonard Fournette's career best is 18.25. Joe Mixon's career best is 17.99. James Robinson, 17.89. So he's right around that range. A little bit above him, we have Josh Jacobs at 19.31. D'Angelo Williams, 19.23. Marshawn Lynch was at 18.9. So, the maximum range there, about 18.45 for Zach Charbonnet, is in that range. So hopefully the RStudio model and the machine learning model gave you a little bit of additional confidence in the analysis that you're doing for each incoming rookie. That's going to do it for today's Rookie Prospect Profile on Zach Charbonnet, presented by Zilla Fantasy Elite. Thanks for tuning in. As a reminder to how the machine learning model functions for those who have not caught it yet, a very broad overview, the model is training and validating and then going backwards to adjust the weights of each connection of each node in the network. It will do this 30 different times to get the closest predictions from the validation portion of the data. So to explain a little bit further or more in depth, The model will go through, on the first epoch, again of 30, training on 80% of the data. It will then predict outcomes of the remaining 20% of the data, called the validation set. It sees how close it was to each prediction, and then will go backwards through each connection to determine how much each connection provided to the error. It will then adjust the bad connections down in weight and boost the good connections up in weight. It will then start that second epoch, again of 30 total, with the brand new weights for each connection and train on the same 80% and make more predictions on the same 20%, that validation set. It then again goes backwards through each connection to adjust the weights. It does this 30 different times. Any more than that, and this particular network will start overfitting the data and becomes worse actually at predicting the outcomes. For reference, there are a total of 14,040 neural connections within this neural network model. At the very end of these 30 epochs, with the best weights at each neural connection, it will then make a prediction on the incoming prospect, given that prospect's own individual inputs. I have the model go through that entire process 100 different times, reshuffling the 80% training set and the 20% validation set for each of the 100 iterations. It makes 100 predictions in totality, and this is what is used for the mean, median, min, max, standard deviation, 10th, 25th, 75th, and 90th percentile outcomes, as well as that mid-50 gap or M50 gap, which is the gap between the 25th and 75th percentile outcomes. The larger the M50 gap, the more spread out the predictions were, and the more volatile the player outcomes can be considered should that prospect ever reach 80 opportunities in a season. The data the model is training on is any running back in the last 10 NFL seasons, so that's 2013 through 2022, that had at least 80 opportunities in one of those seasons. There are 20 different inputs into the model currently, and the output is that NFL players' career best season in fantasy points per game in a PPR setting. There are 243 total running backs with at least 80 combined targets and carries within the model.
Whole crew on top, really we on top. Wake up every morning with drive. Been on the grind, know I had to survive. We had to win. Started from the dirt and the rubble. I had to be the needle that was popping your bubble.